Hello guys, this is Mrs. Figueroa and we are going to be looking at our unit 4B-1, LCD and excluded values of rational equations. Our objective for today is students will be able to find the lowest common denominator and excluded values of rational equations. If you would like to pause the video to write down the objective, go ahead and do so. We're going to move on to the prior knowledge. The prior knowledge of our lesson is asking us to factor the trinomial for part A. So in order to factor a trinomial, I like to do the x, or you guys can do the table, but A times C would be -2 and our B value would be -1. Two numbers that multiply to -2 and add up to -1 would be -2 and +1. So we can use our shortcut. It would be x minus 2, x plus 1, and that would be our answer to part A. Part B is not a trinomial but a binomial, so there's no common factors, so you want to check for a difference of two squares. I have a difference and two perfect squares. So this will end up being x plus 7, x minus 7, because you take the square root of each one that's positive, one that's negative. Our concept for today is on rational equations. So rational equations are equations that involve at least one rational expression, meaning the variable is in at least one denominator. Some examples here, you can see 5x is in the denominator, x is in the denominator, and I also have an equal sign, which makes it an equation. X plus 1, x is in the denominator, x in the denominator, and I also have an equal. Non-examples, you can see in this example there is no equal sign. Here I have an equal sign, but none of my denominators have an x, so there is no variable in the denominator. Therefore, it is not a rational equation. Continuing, our concept says the lowest common denominator, or LCD, of a rational equation is the product of all factors shared between two or more denominators and any remaining factors of the denominators. So main thing for our lowest common denominator, or LCD, rational equation is the product of all factors shared between two or more denominators and any remaining factors of the denominators. So if you were to look at this example, x squared minus 36 mainly we're looking at the denominator, so lowest common denominator. So x squared minus 36 in the denominator is a difference of two squares that splits into x plus 6, x minus 6. And my 2x plus 12 has a GCF of 2, so I end up with 2x plus 6. And then x, I can't do anything to the x, so you just copy it. Excuse me. Then for the LCD, you want to check for the shared product of what they have in common. So this shared, you can see that x plus 6 is shared, so you only write x plus 6 one time. Then I have x minus 6 left over, so x minus 6, and I have a 2 and an x. So my 2 and my x end up over here by themselves. Alright, so let's move on to our first example in our notes, and it's asking us to find the LCD of the equation. So in order to find the LCD of the equation, you need to make sure your denominators are factored out as much as possible. I have x minus 2, x plus 4, and a 6. There's nothing really that I can do to those. So my LCD, you're looking for the shared factors. There is no shared factors here, so they're all remaining. You just want to put the number first, so 6, x minus 2, then x plus 4. And that is your final answer. There really wasn't anything we had to do for this example. The next example is just a practice one. You guys can pause the video and go ahead and practice this. I'll show you the answer in a second. Okay, here is the answer. Now let's move on to the next example. This example we do need to factor. If you notice the denominators, I have a trinomial here, so I can factor my trinomial. So let's go ahead and do that first. In order to do that, I need to copy the numerator, x plus 1, over. Then I want to factor my denominator. So my denominator, I have a trinomial, so I'm going to do my x. I have a times c is -10, and my b is -3. So two numbers that multiply to -10 and add up to -3. My factors I can see would be 2 and 5, but one of them has to be negative. I want a -3, so it's going to be a -5. So then this is going to split into x plus 2, x minus 5. Then I'm going to copy the rest of it. I have minus 5 over. I have a binomial, but I want to check if I can factor anything out. I can see here I have a 2x plus 4. They both have a 2 in common, so my GCF is a 2. So 2 times x plus 2 equals x minus 4 over my 3x. I really can't do anything to the 3x, so I'm just going to copy it. Then to find the LCD, you're looking for things that are shared. So my shared values, I can see I have a x plus 2 in common. So that's going to be one of them. And then this x minus 5 is left over. And I have my 2 and I have my 3x left over. So you want to take all of those and multiply them together. Remember, it's the product of all of these. So I can see I have 2 times 3x, and then I have my x plus 2's, and I have my x minus 5. I just want to simplify this 2 and the 3x because they're both numbers. So your final answer for the LCD would be 2 times 3, which is 6x. And then x plus 2, x minus 5. You don't want to multiply those. You want to leave those as is. So this would be your final answer. Anytime you have numbers, you want to multiply them. So you want to take the 2 times 3 would be 6, and then you have an x. And then your shared values were x plus 2, you only write it once, and then x minus 5, you write it by itself. Here's another practice problem. You guys can pause the video to practice this on your own. Okay, and here's the answer if you practiced it. The answer is supposed to be 3x, x plus 4, x minus 4. So you can see x squared minus 16 was a difference of 2 squares. That's where this x plus 4, x minus 4 comes from. And then the second denominator has a 3 in common, so you can take out a 3, and then you'd be left with x plus 4. And then I have my x out here, so that's where this x comes from. Now let's move on to extraneous solutions. Extraneous solutions are rational equations can have extraneous solutions, meaning solutions that are excluded values of the expression in the equation. For a rational equation, extraneous solutions create a 0 in one or more denominators. Extraneous solutions are not included in the final solution set. Because it creates a 0 in one or more of the denominators and we can't divide by 0, then it would be extraneous. If we look at this, 4 times 5x, if I were to plug in a 0 here, I would have 5 times 0 would be 0, and then 4 divided by 0, we can't do that. We can't divide by 0. Same here. I have 1 over 0. You can't divide by 0, so a solution of 0 would be extraneous and would not be included in the final solution set. In this example, if I see my x plus 1, I want to figure out when would that be a 0. So x plus 1 equals 0. If we subtract 1 from each side, x equals negative 1. That's where this comes from, would be extraneous, because if I were to plug in negative 1, I would get 0. You can't divide by 0. And then same for this one, my x minus 2, you're trying to figure out when would that be 0. So that will be 0 when x equals 2. So 2 is also extraneous. And then in this example over here, if I were to take that and factor it, my x squared minus x minus 2, I think this was the same as the prior knowledge, so negative 2, negative 1, that would be a negative 2 and a positive 1. So this would factor out to x minus 2, x plus 1, which is here x plus 1, and x minus 2 is here. So that's why it's still negative 1 and 2 would be extraneous, because they would make the denominator 0. We cannot divide by 0. So main thing for extraneous solutions, we cannot divide by 0. So in this example, finding the excluded values of this equation, you're trying to figure out when will the denominator equal 0. And that would be your excluded values, is when will the denominator equal 0. So if I were to check my x minus 2 equals 0, I can add 2 to both sides, so x equals 2 would be an excluded value. And then if I take my x plus 4 and make that equal to 0, we subtract 4 to each side, so my x would equal negative 4, would be an excluded value. 6 doesn't have an x, so there's no way that 6 can equal 0, so there really isn't anything to do for that one. So your excluded values, the answer to this, I'm just going to abbreviate that to EV, would be x equals 2 and negative 4. Would be your excluded values, because that is when your denominator would be equal to 0. In this example, you have to factor again, and I think it's the same as the previous example. So if I were to factor this again, I had my x plus 1 over, in this denominator, x squared minus 3x minus 10. That ended up being x minus 5, x plus 2, I believe. And then I have my minus 5 over 2x plus 4. We were able to take out a 2, and then we had x plus 2 equals x minus 4 over 3x. We really couldn't take anything out of that example. So for the excluded values, you're looking for when would x equal 0. So you're really checking at your answer to the LCD, because the LCD has values with the x's. So the LCD that we had before was 6x, x plus 2, x minus 5. So the easiest place to look is in the LCD, and then because those have all the x's, and then you're going to try to see when would this equal 0. So in my first example here, my 6x equals 0. If you divide by 6, or divide by 6 is still 0. And then here, x plus 2 equals 0. You just take the negative. So this would be x equals negative 2. And then x minus 5 equals 0. You would take the opposite, you just add 5, so x would equal positive 5. So your excluded values, again, I'm just going to abbreviate to EV, would be 0, negative 2, and 5, because those three values would give us a 0 in the denominators. And you can double check if I plug in 5. 5 minus 5 would be 0. 0 times anything would be 0. So this would give me a 0 here. And if I plug in a -2, -2 plus 2 is 0. So that'll be 0 times something will still be 0. If I plug in -2 again, that would give me a 0. And then if I plug in a 0 here, 3 times 0 would be 0. And I apologize for the announcements. Okay, so go ahead and take the rest of the class time to work on your exercises 4B1 for your homework.